folks, welcome out there to, hey, our first new season specialized segments. Are you ready for it? This is a Friday show and sometimes a holiday show too that we do. But you know the difference is you get to sit back, relax, we'll do some math. It's not a call-in day, all right? But you can still send us stuff on Facebook, you can still send us on Twitter, you can still email to us, all those great things, and they'll be going along the bottom of the screen throughout the show, all right? But today we're going to talk about some sort of specialized segment, which means topics, okay? And let's see what our specialized segment of the day is today, what we're going to look at. It says different stories, different angles. We're going to go back and do some angle applications. We're going to see a little review, and we're going to be solving some algebra, all sorts of good stuff. So like I said, get those pencils, papers, calculators, whatever you think you're going to need. Let's sit back and let's have some fun. Let's see our first angle problem, guys. Pretty picture here. If y'all want to draw that picture down real quick, here are two angles that are adjacent to each other. And they got some algebra going on. And by the way, these little zeros you see, those are degrees. Those are degrees. We're not raising these to the power of 1. The power of 0, which equals 1. But you know what? That's what we want to look at there. How do those work together? They work together. They're adjacent because they share that common ray, that ray dB. And we don't know how many degrees they are. But it looks like they're obtuse, all right? And you know what kind of verified that for me? That 126, yeah. 126 tells you this big angle is obtuse. Notice this angle CDA. And that's how we name that, by the way. D is the vertex, so it's at the center. So you say, well, Ernie, what are we going to do? How are we going to figure this out? It looks like they come together to make 126 degrees. Look at those. They lie side by side. That's what we're going to do. We're going to create an algebra equation that relates this 126 right into the money, okay? So let's work it. Let's set it up here. So first of all, we're going to set up right here, right next to us what we got here. How about 11x minus that 7? All right, see, that's our first quantity. And if we add that to 5x minus 3, all right? And what's the total of that? That total, according to what we were given, is 126. So now usually you're going to have enough information. Well, usually if not, you can't work it, right? So you've got to take and say, why did they tell me this, and especially why did they tell you that? And why did they give you this word, adjacent? Because they lie side by side. And basically by the angle addition postulate, which we all know and love in geometry land, says these two will add up to give you the big angle measure. Now, let's see the whole big angle is what we're looking for. Nope, we already know that. We're looking for the individual angle measures. That's what we're looking for. So we got to find x, but we're not done with x. That's not the answer. The answer is going to be what happens when we substitute x, the value we get back in. So let's check it out. Let's see what we've got. Putting things together. Oh, I love to put things together. Don't y'all love to put things together here on Friday afternoon? Let's do it. We've got like terms waiting to join forces here. I count 11 and 5. I'm going to get 16 of those. 16x. And I have a minus 7 and a minus 3. Well, bring it together. Let's get a minus 10 out of that, all right? So again, like terms going together, and all that good stuff is equal to 126 over there, all right? Now, we're going to add 10 both sides. Now, hey, this side, you're going like, oh, Ernie, I can do this now. It's good, easy pre-algebra equations, right? Exactly. So let's add 10 to both sides. Now, let me caution you, do not subtract 10. You'll have a problem. You will not get a good answer, all right? I can't guarantee it's going to be a great answer anyway, but it will certainly not be a good one because it will be incorrect. You've got to add 10 to both sides to remove that minus 10, all right? It's the addition property of equality working for us here. So I got 16x, and that good stuff over there is equal to 136. Now that looks a little complicated, so let me go to my trusty calculator here, and I'm going to let it do the arithmetic for me here. I hope it comes out somewhat even. I always like for it to come out even, you know, guys. So let's see what we got going here. We got 136 divided by 16. That's pretty even, all right? 8.5. We'll go with that. We'll go with that. So I'm going to put my x value down here as 8 and 1/2. Now, that's not the answer to the question, though, folks. That's not an angle measure. That is the value that's going to lead us to these angles, all right? So here's what we're going to do. We're going to take 11 times this 8.5, 8 and 5/10, and then we're going to subtract 7. And notice I put a little parenthesis around that. That just tells me we're going to multiply, all right? Then we'll subtract, okay? Oh, I wish we could just go and say 8.5 minus 7 and then do the multiplication, but that's not what the order of operations tells us to do. So we got to do the multiplication first. So again, I'm going to go to a calculator here. All right, let's let it do the work for us. We'll say 11 times 8.5. And then we put in a minus 7. All right, be sure you use the subtraction. Don't use the negative symbol on your calculator. And that's what we're getting. It looks like 86.5 degrees. I'm going to trust it. I didn't miss any keys there. We're going to go with that. That's the degrees, all right? Now, let's see what happens when we take our other one, which is 5 times that 8.5. And then we're going to subtract 3. And we're going to see, hopefully, that those two answers will add up to 126. That's how we check also. But also in this case, that's the question. It asks, what are we going to do? And by the way, folks, show what you're doing. Always show that work. Always show that work. So let's see. We got 5 times 8.5. And we're going to subtract 3. And I'm getting 39.5. And of course, those are degrees. If you add those two together, well, we got a 0 on the end. That's good news. And that means we're going to bring a 1 over here. Those of you are following along with me at home, I see 126 degrees, 126. So it does check out. It does work out nicely. And again, question asks, what are the angle measures? There they are. That is your answer first part. That's your answer second part. We check, they do add up to 126, and all's well, all's well. And again, when we go back and show these substitutions, I know you use the calculator to do the arithmetic, but show what happened and then let the calculator do the work for you, okay? That's what teachers like to see. Show the work, and as always, we love to tell you, and it's important, check. Check, make sure your answers work. So there's our opening problem there, all right? A little bit with adjacent angles, so you get the idea. Different stories, different angles, different stories. Okay, situations are going to be different, but we're going to work with some of the basics that we've learned over the summer, all right? And by the way, those of you who are in a geometry class, high school geometry, and some in 8th grade math are already doing some of these types of problems already this year, okay? Let's take a look at our second problem here coming up. The measure of the supplement of an angle is, whoo, words. Lots of words. Is 10 less than 3 times the measure of its complement. But we know what those words mean. Supplement. Oh, important word. Complement. You guys are good students, right? And of course, we know what the angle is. We're looking for what the measure of an angle is. So there's 3 things we don't know here, my friends. We don't know the angle, we don't know its complement, and we don't know its supplement. Now, if we knew one of those, we could find the others just boom, boom, boom with arithmetic. It'd be very easy, very easy. But what we got to do here is do a little bit of algebra. So Ernie, I don't see any x's. I don't either, but we're going to create somehow about it, or in, or whatever variable you want to choose for your missing angle. So let's go ahead and do some defining, all right? Let's start off with defining. I'm going to let n be my number here. N equals the angle measure. You say, which angle? The angle that we're looking for, okay? Right there, that's the one we're looking for. Now, let's go back to this word supplement. Supplement is going to be, remember, 180 minus that angle. So if that angle were 20, the supplement would be 160, because supplementary angles, remember, add up to 180 degrees. So I don't know what it is, so we put 180 minus n. Be very, very careful here. About to make a big point, and I jump myself sometimes when I do that. But it's not n minus 180. You do that, you're going to have everything backwards in the signs, and it's going to mess up your values, mess up everything. Here's what we're doing. We do 180 minus n, all right, because we're subtracting it from 180. By the way, that's defined as our supplement of the angle, okay? That's going to be a measurement in degrees. And of course, we got the complement. Now, folks, remember, well, supplements are 180. Most of you say, I think I know complements are 90. They add up to 90, that is. Right angles are 90 degrees, but complementary angles do add up to 90. So we're going to use this approach with 90 minus n to find it. Because if I know it's 20 degrees, like I did a minute ago, that would make 70. Now, I'm not saying that's the answer, folks, okay? Because we're just getting settled in here, all right? So here we go. This is the complement of our angle. Now we got to read. Now we got to read what's going on here. I just gave you a what-if situation, but let's see here. It says we start off with the measure of the supplement of an angle. Well, that's our 180 minus n is. Notice that is a big breaking point right there. In other words, we're going to put our equals. It's the verb. It's the verb of this sentence. So let's see how this is going to work. We're going to say the supplement, that's that 180 minus n, equals, there's our is. Now let's read the rest of it carefully. It says 10 less than 3 times the measure of its complement. It sounds like a lot, but let's just break this down. Break it down into small pieces. 3 times the measure of its complement. That's 3 times this little guy here. 3 times 90, got it, ladies and gentlemen out there? Minus n. Okay. You say, well, Ernie, aren't you supposed to put a 10 before that? Let's read a little bit more. I got a little carried away. I may have jumped the gun here. No, it says 10 less than. Less than sends that 10 down here as a subtraction to the end, And again, read that through and decide before you write things down. Now, you all are using pencils out there, right? I'm using a good old ink pen here, so I don't want to make any mistakes, although you all know it happens, right? So we're going to keep at it best we can. Now, let's see what's going on with this problem, by the way. It looks like algebra. That's what it is. That's what it is. It's an equation. Let's solve it. By the way, this is another reason why you usually take care of all your algebra and Algebra 1 that's going to be needed to get through a geometry problem of this level. Okay, this is a higher level thinking problem, and also it's a fairly high level algebra look. So let's distribute. Let's distribute. Take care of business here, all right? And we've got, 3 times 90, y'all got that one, 270, right? 270. We got 3 times n, and there's a minus, so don't lose the minus. 3n, put it there as minus 3n. And then we got this subtracting 10 taking on out the end. Now on the left-hand side, nothing happened. Nothing happened, so don't mess with it. Leave it alone. Now let's take a look at the right-hand side. We got a little bit of work that we can do here. We've got 270 minus 10, which is going to give me 260. And I've also got this minus 3n. So let's see what we've got going here, all right? On the left-hand side, we've still got this pesky 180 minus n hanging on, but that's all right. That's good. That's good. But now it looks a little bit easier. Looks a little bit easier. So let's add 3n. Add 3n both sides. And now I'm really liking the look of this. I've got 180 plus 2n. Be careful. By the way, we add 3. We don't subtract 3, okay? We add 3 over here. And then over here we've got equaling to 260. 260. Go ahead and kick your 180 out of there. That's what I would do. That's what I hope we are going to do. And we're going to subtract it. I'm going to go ahead and subtract it off here. You're going to have 2n equals, what happens when you subtract 260 minus 180, folks? And we are subtracting because we're sending it over. So I'll put a little minus 180 here, minus 180 here. Draw another line here. I'm getting 80. 2n equals 80. And how about it? N, therefore, is 40. Now, some of y'all get real excited. Well, that's the degree. That's our angle measure. You say, well, Ernie, that seemed easy. Yeah, but I've got these other things I really want to know. I want to check. I want to check my answer. Make sure it's right. 40 sounded good. That means if I'm going to put a 40 here, I'm going to get 140. So there we go. And if I come along here, let me make those a little prettier. Yeah, there we go. The complement of that angle, well, that's going to be what? 50, right? Subtract 90 minus 40, you're going to get 50, okay? So let's see if that works. See if these degrees make sense. Now this is what we're looking for. That's the answer to the question. All right, find the measure of the angle. We're going to check. So first of all, if I put this supplement back in here, that's going to be 140. So I'm going to kind of put it right down here. I got 140 on the left side of this equation. And I'm going to say 3 times the complement. 3 times the complement is 3 times 50. And then guess what? We subtract 10. If that gives me 140, my goodness, it all works. Great answers. By the way, we're going to get 140 out of that. See if I can make that work. Equals 150 minus 10. You all tell me. I believe we got 140 on the left, 140 on the right, and all's right with the world, at least on this problem, all right? That is a tough one, folks. But if you will just at the very beginning define everything you don't know. Define everything you don't know and then just fit that into the words, replace the words with the symbols. It becomes very easy to solve these problems, and then you rely on your algebra. And of course, at the end, hey, check. Does it make sense? This one does. All right. So there we go. Second problem down. And you know what? It's very straightforward. It's very straightforward. Angles are fun. They are fun, especially when things come out even like those are doing, right? Let's take a look at our next one here. This one's a little bit interesting. It says angle 1, they're all interesting. You know that. Ernie says that about every problem, right? Angle 1 and angle 2 are complementary. That tells me they're going to measures are adding up to 90, all right? So that tells me right off the bat that measure angle 1, yeah, plus measure of angle 2 equals 90. Notice that M, that's what that M stands for, is measures. All right, it just stands for measures. But what we want to figure out is, well, not only what X is, but what happens when we replace it. All right, what happens when we replace it? So let's see, first of all, we're going to substitute. So measure angle 1, we're going to replace with x squared plus 12. How about that? And we're going to add 40 minus 2x. And we're going to get a big old whopping 90 out of that, all right? When we put those together, that's a 90. Sometimes my little ink pen makes little spludgies. All right, let's see. That's a new word. Look it up in the dictionary. Let's see. We've got x squared heading the way here. We have a minus 2x. We're going to run this thing because x squared's not disappearing. So we're going to run it like a quadratic, which is exactly what it's going to become here. We're going to put in minus 2x. Make sure your signs are good there. And then we're going to go ahead and add this 15 and 40. They're on the same side of the equals, so we can add those together. It's going to give us 55. And on the right-hand side, folks, we got a big old 90. Now, what do we got to do here? It's a situation where we can't get rid of the x squared. We want to factor. Oh, yeah. We want to factor, if it'll factor. First of all, let's find out if it does. And to do that, we've got to set it equal to 0. That's right, 0 out there, folks. So let's get rid of the 90. Subtract 90 from both sides. Subtract 90. So when we do that, we are going to end up with x squared minus 2x, minus 35, because that minus 90 makes that 55 go to negative territory when we subtract 90 off there. So watch your signs. And it's going to be very important. Our signs got to match, got to work here, all right? So this tells me if we're going to factor, and we're going to try anyway. Let's see what happens. Break those down into 2 parentheses. I got x, and I got x, because that gives me x squared right there. All right, everybody good? Now, where am I going to go? I'm looking for factors of 35. Factors, that means how we multiply. Well, there are not many ways to get 35. That's good news. 7 and 5 will work. 1 and 35. And which of those will subtract to give me 2 in the middle? That's really what I'm looking for. So because I want a negative 35, I've got to have a positive and a negative down here, okay? And what happens when I add a positive and a negative? Well, whoever's larger is going to win out in this case, all right? Because we've got just simply x and x on the front. So I think 7 and 5 look good. Let's put the 7 with the minus, and we'll put the 5 right there. Options. You say, Ernie, they're options. Oh, they're options. Oh, they're options. Yes, let's check them out. We have possibility that x plus 5 could equal 0, or x minus 7 might equal to 0. The way I see it, right down the line here, I see 2 answers. You see 2 answers? We all see 2 answers. First one is going to be negative 5, because negative 5 plus 5 will give you a 0. This one over here is going to be 7. 7 minus 7 is going to give us 0. Are they both good? It kind of bothers people sometimes. There's 2 answers, 2 possibilities. Well, let's check and see. So first of all, what we're going to do, we're going to come back up here. We're going to write x squared plus 15. And we're going to also work with this 40 minus our 2x. Y'all got it there? We're going to check. Do they work? I mean, it could be I could have possibly picked up an extraneous answer. I don't know. Not until I check. Not until I check. All right? So let's see. By the way, extraneous means extra. It's a fancy word, isn't it? But I could have come up with something that really doesn't work. It's an extra answer that doesn't actually solve the problem. So let's see what happens. Let's put that negative 5 in first, all right, for x. We'll put a negative 5 and square it. By the way, folks, if you're putting that in the calculator, I hope you're not. But if you are, it's a negative 5. Put it in a parenthesis before you square it. Or it's a negative 5 times a negative 5. Otherwise, you're going to get a strange answer, like something that's going to give you a negative angle. Doesn't work, all right? So here we go, plus 15. You know what I've got here? I have a great answer of 40. That's good news, all right? Let's take a look at this little guy. We're going to have 40 and we're going to subtract 2 times that negative 5. Now remember, negative times negative actually gives us a positive. We multiply first before we subtract. Order of operations. Hey, my dear Aunt Sally rules everywhere. She is forever, ever with us, all right? And let's see what we got. This one gives me, we said 40. This one gives me 50. Oh, they add up to 90. So negative 5 is good. Negative 5 is good. There's lots of times you come up and say, Ernie, you got a negative answer. Does that mean the answer is wrong? No, you don't know until you plug it in or you substitute it back in and get the angle measure, all right? So you go back, put that negative 5 in both of these, and we get good answers, good answers. Now, I hope you're thinking ahead of me. What's going to happen with 7? What's going to happen with 7? Let's find out. We're going to take this x squared plus 15, once again, because that's what we have to work with. And we're going to put in 7. We're going to put 7 squared, and we're going to add 15. But this time it's a little bit easier. Don't have to worry so much because you've got a positive value. And when you square a positive, you know it's going to be positive. So sign mistakes don't usually happen on this one. Now, this next part, you're saying, whoa, that 40 minus, that looks a little tricky. Well, as long as you multiply first before you subtract, you're going to be in good shape. All right? And that's what we're going to do. So it looks to me like we're going to get 40 minus, wow, what is that? 40 minus 14? 2 times 7, 14. And I believe we're going to have 26. All right, think about your money. I can do that in my head. I can think about money really all day long. It's kind of nice, isn't it? Let's see here. 7 squared is 49. Add 15 to that. We have 64. Question, do they add up to 90? They certainly do. You got 2 options, and both of them were good answers. Both of them were good solutions. Would you have known that unless you checked it? No. Okay, and that's the deal. That's why we go through here and go through this process. And in this case, it says find the measure of both angles. Well, first of all, you'd have to give 2 sets. This one over here is 50 and 40. 40 and 50, there you go. Those 2 work together. That's 1 set of answers. Here's the second set, 64 and 26. And of course, this one was angle 1, that's angle 2, in the way that works there, all right? And so you can come back up there. So you're looking at 2 possible options, and they're both good answers, good solutions. That happens. It happens, okay? Especially when we get quadratics rocking and rolling around. That's our x squared business. All right, now I got a couple quick questions at you here. Let's take a look at this one here. It says, what if 2 angles are both congruent and supplementary? So that means we want 2 angles to have the same measure. That's what congruent means. What congruent means. And they're supplementary. That means they add up to what? 180. So there are 2 important words. That's why, folks, vocabulary in geometry is so important. You know what these words mean. You know what these terms are all about. So we're saying something that's the same. Well, I'm talking 2 angles. I don't know either one of them, but I know they're the same. So let's call them n. How about it? N, and we add up to n. We're going to get supplementary. Now, what's supplementary again? Supplementary angles stay straight, SSS. That means 180, okay? They make, basically, when you pair them out, they get a straight angle effect. But they do. They add up to 180. If SSS will help you keep it straight, no pun intended, there you go, all right? And here we go. 2n equaling 180. I'm there. Divide by 2. Ooh, n equals 90. Now, you said they both are 90 degrees. What kind of degrees? What kind of degrees? We got 90, right? What kind of angles have 90 degrees out there, my friends? They're right angles. So if 2 angles are congruent and supplementary, guess what? They're going to be right angles. Going to be right angles. That's pretty cool, all right? In fact, that's a nice theorem that we learn on down in the geometry class. So that's just a little bit of giving you a little bit of head knowledge. How do you show that it works? Right there it is. You know the 2 definitions. You set them up into an equation. What about my second statement here? It says, question actually, what if 2 angles are both congruent and complementary? So this time we're going to pick our little n's again. We're going to put an n plus an n. You got it out there, everybody? And this time complementary, that's the big key word. By the way, congruent made them the same measurement, and complementary means they add up to 90. Remember that little statement I said, if they're adjacent, you can say complementaries cut corners. Just like when they were adjacent supplementary, they stayed straight. Complementary, CCC, all right? And that means they add up to 90 degrees. We're going to put those together. This one's easy. 2n equaling 90. And you know what? I get, you get, we all get 45-degree angles. There we are. All right, so those two angles would both be 45. Obviously, that adds up to 90. They're obviously the same. Up here, 90 and 90 gave us 180. So there's some thoughts. Sometimes we put two types of angles into one problem. Woo, how about that? Just think a little bit, just taking a little thinking. And we could do some other algebra depth on that, but not today because we're about out of time. But I want to let you know, thank you for tuning in this afternoon with us. And you know what? You can find us on, I believe it's Facebook. You can find us on YouTube. You can also write us on email. And we're glad you're with us today. That's the best way we go. We'll be back again live this coming Monday, and you can call in with your problems and talk to me. But thank you for tuning in with us today. And as always, I hope you have a great weekend.